students, till now we have covered most of the concepts in C programming like structure, pointer, arrays, then dynamic memory allocation, then looping, everything we have covered till now. Now in this lecture I am going to explain the next concept, that is file handling in C programming. Let I want to create any text document, and with .txt extension that file will get stored permanently onto the secondary storage device. Secondary storage device means what? See, hard disk means whatever you are storing in the form of file inside a computer system, that is a permanent storage. Means after some time you want to open that file again, you can do that. We are creating any Word file, any document, again the same thing is there. We will use Microsoft Word for that. We will open that Microsoft Word, then we will click on that new document, we will type something, we will save that file. After clicking on that file save option, it will ask for name, we will give some name, that file will get stored permanently. Getting? Now whatever stored inside computer system, that is always in the form of files. Now what is the linking of this C programming and this file handling? If you want to do some operations on any data using our C program, then what we do? We will ask from user that enter something. A user will enter something through keyboard. Our program will accept that, will store inside variables, will do some calculations, will do some processing and gives us output onto the console, that is onto the output screen. But whenever that program execution will get terminated, again if you want that same input and same output, that you will not get. Why? Because whatever input you are giving or whatever output you are getting from that program, that is not permanently stored. Actually that is onto the RAM, and RAM is what? RAM is a volatile storage. Means whatever stored inside RAM, that will be inside that RAM till you are not switching off your computer system or till you are not terminating your program execution. If you are running that program again second time, then whatever previous input, output, that everything will go. Getting? Means after termination of your program execution, whatever you have entered through keyboard, whatever that program is giving to you, that everything will get lost. If you want to give some input to the program which is big, which is very vast, huge, then you can create any file, and through that file you can give input to your program. It is possible. Or suppose multiple programs want to share same input, then again if you have created any file, you can give input to the program from that file. One file can be shared by multiple programs. This is possible, and that only we have to see in this lesson. Now what is this file handling? Creating any file using our C program. Already created file is there. Suppose you want to read contents from that file, then reading a file, writing some extra contents into that file, modifying whatever created contents, whatever created file, then moving to a specific location into the file, or closing a file, opening a file, everything is possible. And these all operation if you are doing with file, then that is nothing but file handling. Getting? And that is possible using C programming. Now see, suppose this is a hard disk and you have created any file. Now what is this? Some portion of that file, hard disk, and there you are storing some sequence of bytes, this collection of data that is in the form of bytes, binary format. And if you are giving some name to that file, this is what? This is nothing but a file. Means file is nothing but a collection of bytes stored on any secondary storage device. That may be a disk of some kind. Disk means it may be a hard disk, it may be a pen drive, it may be any secondary storage device. whatever stored on secondary storage device, that is always permanent storage. And what is primary storage? RAM is the example of primary storage. Means whatever you are storing onto that RAM, that is not permanent. Whenever you are switching off your computer system, whatever data onto that RAM, that will get totally erased. Now you can do multiple operations on this file. You can open that file, you can create a new file, you can write some contents onto the file, you can modify already created contents, you can read a file, you can write to a file, you can open file, you can close file, you can move to a specific location onto that file, into that file. Means that is nothing but seek operation, that is called as a seek operation. Now there are basically two types of files, those we have to see now. The first one is a text file and second one is a binary file. Text file and binary file, the name of this file itself indicates its meaning. In text file, whatever information you are storing, whatever data you are storing, that is in textual format. Means here data will be stored character by character in character based format. Okay, character based storage is here and it is in ASCII format. ASCII means American Standard Code for Information Interchange. For example, we already seen this ASCII concept. Means if you want to store capital A inside a file, then its ASCII value will be checked, that is 65, that will be converted into the binary format and then it will be stored. Means whatever storage that is inside in a ASCII format inside a text file. And if you are using binary file for storing something in a computer system, then that is in a binary format. Means it is in the form of bytes. Byte by byte information will be stored. Best example of this text file is nothing but .c file. If you are creating any C program, normally we store C programs using .c extension. For example, suppose we have created any addition program and we can give name like addition.c to that file. Then that program will be stored in a textual format, in ASCII format, and that is nothing but an example of text file. Suppose you are creating any text document using notepad, then .txt extension will be there, like let file1 .txt. Then what is this? This is again a text file. Getting? Now what is the example of binary file? Binary files, the extension is .bin, the extension may be .exe, any executable file. The compiled version of this C program, that is nothing but example of binary file like addition.obj. We know that object file is always in machine language and that is internally stored in a binary format. That is the best example of this binary file. Now how to check whether any file is text file or binary file? There is one solution. Using notepad, if you can open any file, like suppose this file you can easily open with the help of notepad. You can see all the contents you easily. Then you can say that that is a text file. But this type of file, if you try to open with the help of notepad or again any C editor, you cannot see the contents, you cannot understand the contents, because whatever contents stored internally, those are in binary format and you cannot understand that. Your editor, even notepad or any C editor, you cannot understand that and you cannot see that content, you cannot read it. These are not readable, but these are easily readable. And we can create externally these files, but these files we cannot create. This is the difference between text file and binary file. Now some other differences are there. The first difference we have seen that here data is stored in ASCII format, character by character. Character based storage is here in text file. In binary file, the storage is in a binary format, byte by byte storage is there. These are normally opened using any text editor. We can see the contents. but here you cannot see the contents. Getting? We have seen string concept in this C programming. What is string? String is nothing but a collection of characters that is terminated by null character. That there is a terminator symbol. That is a null character will indicate that this is the end of string. In the same way, whenever we create any file, there should be any termination indicator. Means this is the end of file. Because if you are reading that file, then where to stop? That will be indicated by a character, that is a end of file mark. Okay, now that EOF or end of file, how that will be indicated inside text file and binary file, there is some difference. Now see, in case of text file, character by character storage is there. After completion of all the data, if you have written using this textual format, then at the end EOF character will be inserted. This EOF is a character and that is actually a macro defined inside stdio.h header file. Whenever you are reading that file, whenever you will get that EOF character, that means you can say that now this is the end of file. And here the ASCII value of this one is a 26. Here you should know the ASCII value because whatever stored inside text file, that is in ASCII format. Getting? Now in case of binary file, there is no any such a EOF character because storage is not in character format. That is in binary format, bit by bit, byte by byte. Data will be stored. Now in case of binary file, for EOF, which is the indicator, here the number of bytes inside a file, that number will be stored. This binary file or your operating system will keep track of number of bytes inside that file if you are storing that file in a binary format. Total number of bytes of a file that will be stored. Suppose you are adding some contents inside that file, again this will be increased. Let you have added some 5 bytes inside that file, then it will be 25. Getting? This is nothing but how the end of file mark will be there inside a text file and in binary file. Let I want to store this file using textual format. Then it will consider this H as one character. It will check its ASCII value and then it will convert it into machine language and will store. Getting? Now then E, then L, L, O. And there is one difference, that there is a /n character is here. /n indicates the new line because here we are moving to new line and then we are adding some contents. Now this /n, how it will get stored in text file? Here instead of /n, it will write /r/n, 2 characters at this place inside a text file. To write into the file using C program, we have some inbuilt library functions. Like there is a putc function that we can use to write a character inside a file. Now using that, if you are writing like this /n, just write there /n character, means I want that cursor should be shifted to the new line inside that file. Then this character will not be written as it is inside a text file. Internally onto the hard disk, instead of this single character, it will write 2 characters like carriage return, line feed. This combination of these 2 characters will be written inside a file onto the hard disk. And whenever we are reading that file, then again this will be converted into a single /n character and will be shown. Getting? This is nothing but how /n character will be stored inside a text file. But in a binary file, no such translation will be there. It will check that character, its binary format, it will check and will store directly as it is. Here see, number of characters are like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Because again there is one EOF character. 19 characters are there inside this file. But inside operating system, if you check the number of characters inside that file, it will give you 20 value, because instead of this /n, slash and slasher combination will be stored in using, means operating system will read these two characters because that as a separate characters, because it will be stored in this way, like slasher slash r slash and combination. If you are trying to read that file using any inbuilt functionality inside std.h, whatever available, then you will read that as a single character. It will read that as a single character. But in binary file you will not get one byte extra. Getting? This is the difference in text file and binary file, how that slash and character will be stored. Now the next difference is how the numbers are stored inside this text file and binary file. See, numbers means what? See, I want to store this 1, 2, 3, 4, this number inside a text file. Now how many bytes it will take to store this 1, 2, 3, 4, that is 1234. See, in text file the data will be stored character by character, means first it will take this one character, will check its ASCII value, will convert it into binary format, and then it will be stored inside a file. Here 1 will be stored, then again 8 bits, there 2 will be stored, again 8 bits, that 3 will be stored, and again next 8 bits, that 4 will be stored. This 8 bits means 1 byte, means this 1 will take 1 byte, 2 will take 1 byte, 3 will be take 3rd byte and 4th byte, means 4 bytes will be required to store this 1234 if you are storing this information using this text file format inside a hard disk or any secondary storage device. Getting? Now if you want to store any floating point value, let 24.726 suppose, this you want to store inside a file, then this number will be stored, like 2 will be considered as one character, 4 will be as a one character, this point that will be again considered as one character, means it will take 5 bytes to store, because text file will store data character by character. Getting? Now see, if you are storing this in a binary file, then it will take 2 bytes. Normally this type of number, this is a small integer number, it will take 2 bytes are sufficient. That whole number will be converted into binary format, and as it is, it will be stored in a memory if you are storing it in using this binary file format. It will take 2 bytes and this will take 4 bytes, because this is a floating point number. Now here it can be stored easily in 4 bytes. Getting? Now this is the difference how the data will be stored in text file and binary file if it is a numerical data. See, we have seen already that point, that is textual information we can easily read using any text editor. Means if you have stored any data using text file, then it is easily readable. But if you are stored in a binary file format, then you cannot read that using any text editor. How? See, let I have stored this 1234 using text file. This will be stored internally in 4 bytes. Like here 1, its binary format will be stored, 2, then 3, then here 4. It will check its ASCII value, will convert it to a binary format and will be stored inside these first 8 bits. Then here again, say. Any text editor, suppose want to show you any file, then how it will do that? It will take first character, first byte will check its ASCII value, will convert it to that character, and then it will show on to the text editor. Means this whatever information stored here, it will convert it into the character, and that character will be showed as a character onto that text editor. Then next character it will read and will show like this, will read, show like this, 4 will read and show like this. Let you have stored this in binary file format, then this 1234, its binary conversion will be stored in 2 bytes. Why? Because integer will take 2 bytes to store in a memory, these small integers. Now here this 1234, the whole number will be converted into binary format and will be stored here inside these 2 bytes. Now whenever text editor want to show you this file, then it will read first 8 bits, will convert it to that character and will show you that character. That's why you can say some symbolic text onto the text editor. Why? Because whatever character which is equivalent to this binary format, whatever this first byte, that is not like this 1 to 12 or nothing, because this is whole number will be converted into binary format and that will be stored here in 2 bytes. That's why you will get any character which is equivalent to this 1 byte and it will show you like this, maybe like this, means it is not in readable format. You cannot read using text editor whatever stored in binary file format. These are all differences between text file and binary file. Getting? Now see, the next point is different file operations possible onto the file. Means like we have created any file, you can read that file, you can write some contents to that file, you can open that file, you can close that file. These are nothing but file operations. Now let us see one by one. See, creating a new file means like you want to create any new file which is not already present inside onto the hard disk, then that is possible and that is the creation of new file. This is the first operation. Next one is opening an existing file. If you want to read any file whatever already created, or you want to modify some contents from that file, then you have to open that file first, then only you can read that file, you can write to that file, you can modify contents from that file, everything you can do. For that first you have to open that file. That is the second operation, that is opening an existing file. Existing means it should be there, then only you can open that file and you can read that file. Getting? Now next one is writing data to a file, means if you want to write something into that file. The next one is you can read a data from existing file. Suppose you have created already any file whatever present, or there is any file present onto the hard disk, then you can read that. Then that is nothing but reading data from any existing file. Then moving to a specific location in a file. Moving to a specific location means let there is a file like this, there are some contents inside that file. Initially whenever you will open that file, the file pointer may be here at the beginning, and let you want to read this third line directly, then you can move this file pointer here and then you can read that file. This is nothing but moving to a specific location in a file. This is called as a seek operation. Getting? And now last one is closing a file, means after doing all operations you have to close that file. These are all possible operations onto the file. Now let us see one by one. Now for doing all these operations, C has provided different functions which are built in and which are defined in this stdio.h header file. These are already defined functions, predefined functions we can use for all these different file operations, like opening a file, closing file, reading from that file, writing to the file. Everything we can do with the file using C program, and for that we have to include this stdio.h header file, because whatever operations, whatever functions present inside that file, those we have to use for these operations. Like to open a file we can use this fopen function. Okay, then next to close a file we can use fclose function. To read data from file there are multiple possible options, means you can read character by character. For that means one character at a time. For that we can use fgetc function. Fgetc is to read a character from file. FgetS to read whole string at a time. That we can use fgetS function. Then fscanf function. Read function, that is for record based reading. Getting? Now see, we will see all the file functions, file related functions whatever present in stdio.h one by one. But before that we will see one program here. Now to get some idea about what is this exactly file handling, how to do that with the help of C program, to get some idea, some basic idea about what is this exactly, this file handling concept, we will see one program first and then one by one we will see all the functions. See, here I want to read a file. Already there is a file created using any text editor, or let you have created any C program, that is a source file is there already present onto the hard disk. You want to just read that file and display all the contents of that file onto the output screen using C program. Then for that, how to write a program? See here what we have written, just see and try to understand it. Now here this is a comment like display contents of a file onto the screen. We have already created any program1.c file. Already there is this is present onto the hard disk, and just I want to open that file, read contents from that file, and whatever contents I want to see that onto the output screen with the help of this program. This is not program1.c. This program I am creating now, and will save this file using any other file name, or this is already created. Suppose addition program we have written in using C language, and that already saved using this program1.c. Whatever source code present inside that file that I want to see onto the output screen using this program, that is possible. Void main means just this is a main function of every C program. We have to write this one. Next, file. This is what? This file, capital F-I-L-E. This is already defined structure which is present in stdio.h header file that we can use in our program directly for file handling. Means for file handling we have to compulsory use this file structure which is already present, already defined, predefined in stdio.h header file. We have to compulsory use this in every program for file handling. Getting? Now file pointer, this star indicates that this is a pointer, and here I have given one name to that pointer, that is fp. File pointer, this fp is called as a file pointer, means this is a pointer to the structure file which is already defined. Now character ch, we have declared here one character variable, because here I am going to read a character, that data from that file character by character. We will read one character, we will store inside this variable, and we will just display this character onto the output screen, like up to EOF, because we have seen already that point, that is every text file will have EOF character at the end that we can use here. Now here what we have written, see, fp is equals to fopen. See, this fopen is a predefined function which we can use to open a file. Means for doing any file operation, even for creating any new file also, first we have to open a file. See, we have to open a file, and for that we can use this fopen function. Fopen in bracket I have passed two arguments. First one is file name and second one is file opening mode. These are the two arguments that we have to pass to this fopen function. What this statement indicates, that open this file in read mode, because I want to just read contents from that file. Getting? That's why I have written like this. The name of the file is program1.c. Name of this file is program1.c. and I want to open that file in read mode. See here, this R I have written in this double quotes, that is a string argument. String means it is enclosed in double quotes. Always keep in mind, if you are writing here only single R, don't use single quote. Compulsory we have to use here double quotes. And this is nothing but a file name, that is again a string that we have enclosed inside double quotes. Now fopen function, what it will do, it will open this file. Means what? See, this file is present where? Onto the hard disk. It will just copy that file. It will just take that file onto the buffer. Means inside a RAM it will just put that file. Getting? And now you can do any operations on that file See, this program1.c is onto the hard disk. Anywhere there may be this file program1.c. Speed of RAM is high as compared with hard disk. Means if you want to just directly read contents from that file from hard disk character by character, that is very hard. It will take too much time and not possible. And that's why this fopen function, what it will do, it will just copy whatever contents of that file here, and here one character pointer onto the first character. See, to the first character it will set one pointer. Everything will be done by this fopen function. Again I will explain the whole thing while explaining this fopen function in depth. Now see, just here try to understand that whatever contents of that file will be copied inside here in a RAM, and whatever operations you want to do, you can do with this. And after closing that file, whatever modifications you have done in this here, those will get affected here. That is okay. But here I am opening that file in read mode, means just I want to read contents, that's why no modification. Here it will copy that file character by character, we will read. After closing that file, this connection will be lost, this will get erased from this RAM. But here still this is here, because this is permanent storage. Now see what this fopen function, it will open this file, means will copy this contents of this program1.file here in RAM, and will set the initial pointer, that pointer to the first character of that file, and whatever data about that file, that will be stored inside this file structure. This file structure will have whatever information about that file. Getting? Now, and pointer to that file structure will be copied here inside this FP. Now see, let this file is not present onto the hard disk, then this is not possible, because whenever we will open that file, our program will search that onto the hard disk, but this is not present, then this fopen function will return null. Otherwise it will return that file pointer, and that will stored inside this FP. Getting? Now we can write here like, if that FP equals to null, then exit 1. What is this exit function? Exit means so it will terminate the program execution, and for using this exit function we have to include that stdlib.h. Here also you have to compulsory include like that stdio.h. And for using this exit function, again you have to include that stdlib.h also. But if it is not equal to null, then this operation is successful. Now file has opened successfully. Now we can read character by character data. That's why I have placed here loop. This while 1 is nothing but an infinite loop. Now we have to break this using break keyword. Ch equals to app get cfp. What is the meaning of this one? App get cfp means from where this fp pointer is pointing, from that file just read a character wherever that pointer to the first character is there. Okay, now it will read that character, means there is one get pointer, that is for reading. If you are doing write operation onto the file, there is a put pointer. From that get pointer, wherever it is, initially whenever you will open file in read mode, that get pointer is here at the first place. Means it will point to the first character from that file. It will read that character. This appgetC function will read that character and will return that character. And for that we have to pass file pointer only. Always remember, we will not use that file name inside any function. Only in a fopen function we will use that file name, that initially whenever you are opening that file. Afterwards you have to compulsory use that fp, that file pointer, for all operations. Getting? Now here appgetC fp means where that fp is pointing, from that file just read the character wherever that get pointer is pointing, and just it will return that character, and that will be stored inside ch. Let here the file is like hello world. only hello, then it will read that H character first and will be stored inside CH, and then shift that get pointer forward by one place. Getting? Like this it will work. Then next, if ch equal to EOF, we have checked, because if this character is EOF, because we know that at the end of file there is a EOF character always in text file. If that character is EOF, then stop. Okay, that's why I have placed here if ch equal to EOF, break. Otherwise ch is not equal to EOF, means here it is H. It will display that H onto the output screen, just like we have used here simple printf statement that is used to display whatever onto the output screen console. Now here it will display that ch onto the output screen. Like this is the output screen of our program, it will display that H. Next, again while one, because of while one, again control will go here, will read that character, next character, wherever that get pointer is, it will read that E, will store inside ch. Again it is EOF, no, again it will display that E here, again same thing up to O. At the end, whenever after O, it will shift that get pointer here, and there is EOF character, it is having ASCII value 26. It will read that EOF character. Now here it is EOF, it will stop. It will come out of that loop instantly at that point. Getting? Because EOF, no need to display over here. Now next, printf /n, only this is only for going to new line onto the output screen. It is not compulsory. And finally it will close that file. Closing a file means what? This linking will be erased. This means this file, whatever contents from that RAM about that file will get totally erased. In this way we can read contents of file which is already created. Okay, now I think you have got some basic idea about what is this file handling. Now let us see one by one all these functions like fopen, then fclose, then we have used here fgetC. All these functions we have to see again one by one in depth. And again we have to see these opening modes. Means here we have used this R. This is what? This is a file opening mode. Means this indicates that for which purpose you want to open that file. Means you can open file for reading, writing, appending. This read mode means reading from a file. Writing, for that W mode we have to use. Appending, for that A mode you can use. There are some other modes like R plus, A plus, then W plus, then RB. For means if you want to read a binary file, then again that is possible with the help of C program. Getting? Then these all points we have to see one by one. Now see, opening a file, what is this exactly? See, whenever we open our stored file, like if you have already created any text file, then how we will open that file? See, text file is whenever we create any text file, like we have used Notepad for that, we will type, or any other text editor also we can use. We have created any file, we will store that using any file name, and that will get stored onto the hard disk. Let abc.txt, this is a file. Now see, I want to open that file. Then what we do? We will again open the text editor and we'll click on that file open option. We'll select that abc.txt name and that file will get opened. But internally, what is behind the scene, what will happen? See, internally there is a RAM. RAM is what? It is a primary storage, and this one is a secondary storage. Primary storage means this is a volatile storage. Volatile means whatever contents at the time of working, whatever data on which we are doing any processing, that will come over here for processing. Means see, whenever we will give that command like open that abc.txt file, then what will happen? That file will get loaded onto the RAM, and then we can see that file on our text editor. We can do any changes onto that file, those will be here only, and then whenever we save that file, then those changes will get affected in this permanently. And now what is opening a file? Opening a file means actually internally we will load that file from hard disk to RAM for processing. Why? Because RAM is a faster memory, means whatever read write from RAM is faster than hard disk. As compared with hard disk, RAM is very high speed. Getting? Now in the same way, here in C programming we will open a file. How to open a file? We will just use that fopen function for opening a file. See, this function we have to compulsory use for doing file operations, because for doing any operation with file, first we have to open that file. Now what is the syntax of this fopen? See, the syntax is like this: fopen. Here it will return file star. File star means what? File star is nothing but a file pointer. See, file is a built-in structure which is already defined in stdio.h header file. This stdio.h header file is having this file structure which is predefined, and that will store information about file which is opened, like number of bytes in that file if it is a binary file, or the information like for which purpose the file has opened, for reading, writing, means file opening mode, file name, then location, then again end of file mark if it is a text file. Then next one is about where is the pointer, that get pointer or put pointer. Get means if you are reading that file, or put pointer means if you are writing to the file, then where is that position of that file pointer, that get or put pointer. Everything, every detailed information about that file will be stored inside that file structure, and pointer to that structure that will be returned by that fopen function. That's why return type is file star. Function name is fopen. Now we have to pass two arguments here. First one is like const char star. Const because it is fixed. Const char star file name. First argument is file name, we have to pass file name, and second argument we have to pass file opening mode. We have seen that file opening mode is again a string like R, W, R plus, W plus, RB, whatever. Now here next one is const char star opening mode. Getting? This is just a prototype for fopen function. Here fopen function, for that first argument is a file name, that will be the string, and second argument is file opening mode. There are different modes like R, W, R plus, W plus, A, whatever. These are in string format. After calling this function fopen function, what it will do? For example, see here file star fp, and we have written like this, like fp equals to fopen. Here suppose program1 dot c, this is a file name, and I want to open that file for reading. Then we will use fopen function in this way. That how it will act? See, fopen function will check for this program1.c file inside a disk. If yes, then it will ship that file into RAM. It will load that file inside buffer inside a RAM. Now whatever information about that file, like location inside a RAM, number of bytes or number of characters from that file, we are opening mode, currently where is that file pointer, everything that information related about that file will be stored inside that file, and that file pointer will be returned, and that will be stored inside that fp. Getting? In this way it will act. Now if this file is not present onto the disk, then it will return null, because this whole operation is now not possible. That's why it will return null. Getting? Now see why this is needed, means this program1 should be transferred into the buffer. Why? Because this is nothing but a RAM, this is high speed, and this is a disk, this is having low speed, means whatever read write operation, those are faster in case of RAM than disk. That's why whatever contents of that file will be loaded onto the RAM and will be stored in this buffer, and whatever information about that file will be stored inside this file structure, and its pointer will be returned here by this fopen function. Everything will be done by this single statement. Now what about this mode? Now here we have used R. R is for reading. Now see different file opening modes. In a fopen function, first argument is file name and second argument is file opening mode. We have already seen this R mode. If you want to open any existing file for reading only, then you can use this R mode. R mode is nothing but open an existing file for reading only. Only reading is possible here. Okay, and it should be present there. If that file is not present onto the disk, that fopen function will return null. Getting? Next one is W mode. W means for writing. If you have opened any file for writing, means if you want to create any new file, then you have to use this W mode. See, for creation of new file, we have to use this W mode. How? See, if any file you are opening using W mode, and if it exists on hard disk, already present onto the hard disk, then that fopen function will erase all the contents of that file, and it will be presented as a new file if you have opened that file in W mode. And if it is not present onto the hard disk, then it will create that file. Getting? Only in case of if there is no any disk space for creation of new file, for storing any extra information, then only this function will return null, that fopen function, if you have opened that file in W mode. Means what? Open a new file for writing only. Here reading is not possible. If file currently exists, means if it is already there, it will erase already whatever contents from that file. Means that is nothing but truncate. Truncate means erase all the contents. Means that will be presented as a new fresh file. Means you can say that will be destroyed and new file will be created. Next mode is A. A means A stands for append. Appending means attaching new contents at the end of file. See, if that it will check whether there is a file onto the hard disk present, already present, let abc.txt. If it is already present, it will open that file, and initially cursor, whatever put cursor, because appending means just writing contents at the end of file. Means it will open that file if it is present, and will initially the cursor will be at the end, and from that you can write the contents inside that file if you have opened that file in A mode. If you are opening in file in A mode and it is not present, then no problem, it will create a new file and cursor will be at the beginning. You can add contents. It will act just like W mode. Getting? Now next one is R plus. R plus means some additional functionality inside R. R means only for reading, you can open that file. But R plus means reading and writing both possible. See, if you have opened any file in R plus mode and if it is not present onto the hard disk, then it will return null, of course. But if already that file is present, then you can read contents from that file, and you can just modify also contents inside that file. Okay, you can just attach some contents in that file. Means reading, writing both possible, but it should be there onto the hard disk first, initially. If it is not present, then this R plus, if that fopen function will return null. Next one is W plus means again reading, writing both possible, but here what is the difference? See, in R plus that file should be present, you can do any modification inside that file, means you can write also, but it should be present, otherwise it will return null. And if you have opened any file in W plus mode, then again both possible, that is reading and writing, but if it is not present, then no problem. If you have opened that file in W plus mode, it will create a new file. Getting? Means you can just attach contents, you can write contents in that file, and you can also read again whatever written inside that file. One more point is there, if you have opened any file in W plus mode and if it is already present there, then again it will erase all the contents whatever previously written, and it will present that file as a new fresh file. Then you can just write some contents in that file, and then again you can read that file. Getting? That is in case of W plus. And finally A plus, again just like A, means you can attach some contents at the end, and again you can read whatever written inside. That means reading and appending both possible. If this file is not present, then it will not return null. That fopen function will not return null. It will create new file. You can attach here contents, you can write contents, and you can just read that file. Means it will just act like W plus if it is not present. Getting? This is all about file opening modes for text files. You want to do any operations with binary files, then you can again use that same fopen function, but modes you have to use, like instead of R for reading you have to use that RB mode. Means B stands for binary, R stands for read, and here RT for text file you can use either RT or R, but T is optional because by default if you are using R means this is for text file. For binary file, but you have to compulsory attach here B later. Getting? RB, then WB, AB. For, see here, instead of W for binary you have to use WB, instead of A, B, instead of R plus, RB plus, WB plus, and AB plus. In this way you have to use file opening modes in case of binary files. This is all about file opening modes. Now the next function that is available in stdio.h header file for file operation, that is for closing a file, that is fclose function. Now what is the syntax to use fclose function? Just here we have to use fclose, and here whatever file pointer we have to pass. This is just a syntax of using fclose function. Whenever you will open that file is initially present onto the hard disk, that will be loaded into the RAM inside a buffer. Okay, and in that you will do some changes. You can do some changes. You can write contents in that file, or you can read contents from that file. You can modify the file. Whatever you want to do, you can do, and that everything will be done here inside a buffer. Those all changes will be only here. Whenever you will close that file using fclose function, then only all these changes will get subjected onto the disk wherever that file is there onto the disk. Means those changes will be permanent after only calling this fclose function. Means this is always compulsory to close the file using fclose function after opening that file. Now see, one more point is there. Whenever you will call this fclose function, this buffer will get eliminated. Whatever file structure having that information about file, that will be erased, and only file onto that disk will be present. Getting? This is all about fclose function. Whatever remaining functions about this file handling, that we have to see in the next session. Till then, take care. Bye bye.